fractions, the same rule applies when we're doing algebraic fractions compared to any fraction. In order to add and subtract, we said that we need to have the same denominator. Okay, so at the moment I have a 2 on the bottom and a 3. What number I'm going to make them both look the easiest thing. Okay, so for this, I'm going to have a 6 and a 6. What did I do to this one? I multiplied it by 3, so I do that same thing on the top. So I now have 3a. And this one I have to multiply by 2, so I have 2a on the top. I have the same denominator now, therefore I can just add my numerators. 3a plus 2a is 5a. So my final answer is 5a over 6. How cincy is that? Alright, next one. What's my denominator going to be for 5 and 2? 10. No, it's a subtraction this time. What did I do to my 5 to get to 10? Times by 2. So I'm going to do the same to the top. So I have 8x. What did I do to the bottom to get to 10? Times by 5. So I do the same to the top. I get 15x. 8x subtract 15x is minus 7. Lovely, over 10. Christians? Alright, okay. Now this time we don't have just numbers on the bottom, we've got letters as well. Okay. We need to have the same denominator. So what's the easiest denominator to have looking at these two at the moment? 3a. Ready? 3a. Okay. So 3a is going to be my denominator. So what do I have to do to the left hand side? So I do the same to the top. Do I have to do anything to this one? No. Okay, so I have now got what? Oh, Trivia. Wait. So you're going to have to, why did you make them? Because we're looking at these two. The easiest common denominator to have would be 3a. It's like if we had 4 and 12, I wouldn't make it 48. Like I wouldn't multiply both together because I know that 4 goes into 12. So I would keep them as both 12. And all I would have to do is multiply that one by 3. It's the same kind of situation here. This is a 3a, this is an a, so I can make it the same just by multiplying it by 3. So what you want to say to yourself is, can I make this the same? How can I make them the same as each other in as few moves as possible? Okay. Alright, so what's my current denominator for the big fat 2? 1. So what do I want to make them both? 7. Yes? Do I have to do anything to the first one? No. What about the second? 7. So, no. X plus 14. Oh. Okay, just remember the big fat plus sign. Very clear. I'm not quite sure what it's backwards tomorrow. No, it's just going to be a bit weird. That's 7. So, same situation. Just get slightly more complicated. What is my denominator going to be now? 6. So what do I have to Cassidy do to the left-hand side? Now, what do I have to do when I'm multiplying the numerator by 3 now? What are these ready? Good. I'm going to make sure I'm putting this in a bracket because when I'm multiplying it, I don't want to forget to multiply both of those parts by 3. If you did this up here, if you showed this kind of working up here, you can go straight to writing 3x plus 3 if you wish. It's up to you. It's an extra step of working. But I would rather see all working, we did it right, than try to skip stuff. And what do I have to do to the right hand side? Again, keep it in brackets. So I've got 2 bracket x minus 1. I've now got the same denominator. So when you expand is up to you, but you do need to at some point. Yeah. So perhaps I'm going to expand as I put them all together. So what would this bracket give me? 3x minus 3. And then this, we're adding on 2 lots of this. So we're adding on 2x and we're subtracting 2. I'm stressing this plus sign because you have to remember that if you have a subtraction sign here, it's going to affect everything on the numerator on this side. Okay, we will have an example of that in a second. So far so good? What do I do now? Split like that. So if I have anything like 3x,
I know.
yeah, I think 210 now.
Oh yeah, sorry. Wait.
So the 2x is like that, so I've got 5x, I've got positive 3, take away 2, which is 1 plus 1, and that's all over 6. Okay, so there's my final answer there.
I'm going to judge you about my 6s.
Is that a P? No. Next one. Ashley, what's my denominator going to be for this one? Okay, the other Ashley.
2.
What's my denominator going to be for both of them?
Oh, 4.
Yeah, it's always going to go bigger. Okay, so you're always going to...
Sorry.
I've now got 3 Ashleys in here. It was confusing enough when I just the 2. So you're always going to go with the biggest of the 2. Yeah, you go with that, Ashley? So we're going to have 4s on the bottom. And then other Ashley, what do you do to this one to get to that 4? Yeah. Again, we're going to have a bracket. Should we just... Oh, no. Should we just expand it straight into here?
Yeah.
Okay, so, Laura, what are we going to do?
That would be 4x plus 2.
Trust me, Anne. And then what do we do with this one? Anything? No, so that's just a straightforward 3x plus 3. Now, this is where we have to be really careful, and it doesn't matter how many times I say it, and it doesn't matter how many times I see students nod and yes, yep, we understand, we won't ever do that. They just do. So can you try and be that class that doesn't? Okay? So this subtraction sign affects both of these two things. Okay? So I'm going to have 4 as my denominator. I'm going to have my 4x plus 2. But I'm then going to subtract 3x, and then I'm also going to subtract 3.
Oh,
no, because look, we didn't have to do anything to this.
the top. The 3x plus 3 plus 3. That equals 9.
No, because we're not multiplying by anything.
Oh.
Because it already was a 4, yeah? Yeah?
So it could be 3x minus 3x would then be...
It would be negative 3x plus 3. Yeah.
Oh, yeah.
So you've just got to make sure that this is affecting both of these two terms.
As if it was in like a little bracket, it could be minus 3x.
Exactly. You secretly pretend this is a negative 1 in front of it. Yeah?
Should we write that in the notes or is that?
Please, they are your notes. So later on, like, I don't want you to make those mistakes. So write whatever you need to write to make sure that you don't do that. Because as I said, it's all well and good. I see people go, yeah, I get it. And then I set them on to work and they just make mistakes. So write whatever you need to make sure you don't.
Say you have to multiply the top and it was a fraction before it would be like...
So you do the expansion and then you would change the signs of them. I think we might have one. Yes. Then you would have a positive sign. Yes. And to be honest, they're the ones that most people get wrong. Actually, it's always the second term. The first term they see the negative sign and remember, but the end of the thing, for some reason, it goes wrong. All right, so now we're joining like terms. I've got 4x and I'm subtracting 3x, so I have just x. And I've got positive 2, subtract 3, which is negative 1 over 4.